Hello class, it's just me, Mr. Wee. I just kind of want to go over graphing on your graphing calculator. So hopefully you got a calculator that's similar to the one that I have on the left-hand side of the screen. This is the Ti-84, but if you have a Ti-83, it should be extremely similar to this, as well as the newer Ti-84s that have color and whatnot on here. So it's the same thing. It's the same basic principles. So I'd recommend that you get a Texas Instruments Ti-83 or 84 very soon for this class. Either you could check it out at the library if we have any more, or you can actually get you can get your own from Walmart or Target, wherever you like to buy your academic products and whatnot. So this continues off from the last video part 3, or basically we're going over section 1-6. So let's kind of go over what just happened and graph it. So we have this guy here who we factored out into this guy. Now I wanted to show you first the difference between something that you have x squared. So first let's look at the graphs. So you don't have to write these notes down, but the graphs of a linear graph versus parabolic. Actually, go ahead and write this down. I'm sorry, go ahead and write this down as notes. Linear typically looks like y is equal to mx plus b, or something like an example would be like y is equal to 2x plus 1. Okay? You can imagine that if you graph this, it's going to come out as a linear line, right? I don't know how, but it's going to come out like a linear line. When you graph y is equal to x squared minus 8x plus 12, or otherwise y is equal to ax squared plus bx plus c, okay, in the same way that you graphed y equals mx plus b before, and now you're grabbing this guy, the graph's going to look kind of weird. In fact, I'm going to draw the other side of the axes, because here I only have to draw the y-axis from 0 to like positive number, or the x-axis from 0 to positive numbers, and the y-axis from 0 to a bunch of negative or positive numbers as well. So that's my y-axis, this is my x-axis. Here, I'm gonna draw my x-axis going from the negative to the positive, and then this is the shape I should expect to see. So I believe in some of your work, you're going to have to graph this and make t-tables and graph it out, but this is what you should be expecting to see. So let me show you what that's going to look like on your graph. So go on your graphing calculator now that you should have, that's brand new, okay? And what you're going to do is you're going to first go to zoom, and what you want to do is press 6, or go down to number 6 and press enter, okay? So that just makes sure that ensures that your graph isn't shifted or zoomed in or anything. It's just a nice equal pair of axes. You have the same number of increments on this side as you do this side. Some of you guys might have checked out a library that has the settings tampered with, and it's not at the standard zoom. So make sure, because some people have zoomed out like this. You can zoom out, go to number 3. Every time you press enter, it zooms out. I mean, I guess you won't be able to tell the difference right now, but just go make sure that before you do any graphing, you go to the standard number 6 zoom, okay? After that, go to graph. Actually, not go to graph, go to y is equal to, sorry. And then you can actually put, like, let's say 2x plus 1. Let's say I want to put this equation in. I'm going to graph 2, and then what am I going to put in for x? Well, that says x to the negative first power, and that says next x squared. We're not going to press anything right here in this letter right here, where underneath the letters link, you're going to press this. That will become your x variable. Your calculator will understand that. And you're going to plus 1, and you're going to press enter. So let's see what that looks like. Now we're going to graph it and see what that looks like. It's a linear line, what we were expecting. Okay, maybe not exactly like the one I have. That's not too bad. Okay, and also some cool features about this I want you to try is you can trace it. So when you press the button trace, look, you got like a nice little this is a nice tool in the future that you're going to need for graphing, or you might want to use for graphing. You can actually go along the line, the graph, the actual graph line, and see what kind of coordinates there are. So at approximately negative 1.91, I get the y point of negative 2.829. That just means that if I plugged in negative 1.91 into x here into the equation, I multiplied to 2 and I added to 1, I should get the y value of negative 2.829787. So, and in trace mode, if you're still in trace mode and you press like 5, it'll tell you what the y coordinate is at x equals 5. So that's really handy. So I don't know where it is right now. I think x equals 5 is like right around here. It just tells you what the y coordinate would be. Well, let's just say I want to find out what the y-intercept would be, where it crosses the y-axis. You know that the x value is 0, so let's just put 0 here. Let's see, instead of solving for the y-intercept, I can just find that that's 0, 1 right there. See, it's even telling you where it is. Okay, so it's kind of nice. Some other features you can try, I think I'm getting ahead of myself. Let's just go ahead and clear this really quick. Let's go back to y is equal to. So you have a few options here. You can go to the equal sign and turn off the graph by pressing enter on the equal sign. So look, now I arrow back over to the right and I graph it, nothing will graph because I did not have the equal sign on. If I go back, press left on the arrow keys, press enter, you'll see that's highlighted now. Now it will draw the graph. Okay. So let's go down. Let's deactivate this graph by going back over to the equal sign, pressing enter. Now it's deactivated. Let's go down one. You'll see that there's no graph now, and let's put in our problem, or let's put in our equation, x squared minus 8x plus 2. So let's go down one. Let's put x is right here, where my mouse is, x squared minus 8x minus 8x plus 12 plus 12. Okay, let's go ahead and graph that now and see what that looks like. So it gave me a, It gave me a, what's called parabolic shape or parabola. So if you don't know what that is, so if this was linear, so this is a linear line, this is a parabolic line or parabolic graph, the type of thing that you see here, the shape is a line. And this being parabolic, it's actually a parabola. Parabola. P-A-R-A-B-O-L-A. Okay, so it's a parabola. So that's an interesting thing about these shapes. Only this parabola is a little bit shifted. Okay, you know, I'm curious though. Let's go down one, go to the left, and turn off that equal sign right here. Let's deactivate this graph so there's no graph. Okay, what if I go down twice and put in another equation? Let's put in another graph. So let's pay attention to the right screen now. Instead of picking x squared minus 2x minus 6, or I'm sorry, x squared minus 8x plus 12, let's put x minus 6 times x minus 2. So let's go back to our calculator here. You're going to open the parentheses here. So you're going to do x minus 6, close that parentheses, just like how we wrote it to the right here. Let's go back to the calculator, open the parentheses again. You're going to have x up here minus 2. Let's see what we should get. Let's graph this. Okay. Oh, I see a parabola. Is it different from the last one that we just did? And if let's see. Well, just for some fun right here, go to the left and turn on the line and then graph. And you can see that you can graph two graphs at the same time. Go back to y is equal to. Turn off this though. We don't want that. So let's graph again. You'll see only that last third equation. Let's press y is equal to again. Only that last equation right here is showing up. What if I turn on the other guy? What do you guys expect to happen? Let's turn off the second graph. Let's see what happens. It's loading right here. You can see the lines. Oh, it's done loading. How come I only see one graph? But I have two equations on. I think I only have y2 and y3 showing up. Well, if you think about it, what we have up here, let's go back to the right screen here. What you have is this guy and this guy. Remember, I'm factoring this out, but they're the exact same thing, only it's written a little bit differently. This and this, what we solved for, are the exact same things. X squared minus 8x plus 12, if you factor out into x minus 2 times x minus 2, or x minus 6 times x minus 2, they're the exact same thing, They will give you the same graph, only you just changed the way it looks. Okay, so one last thing I'm going to kind of go through. Don't put away your calculator just yet. We're going to use it in just a second, but one last type of problem that you might see is this. Okay, so I'm going to draw this out so don't be confused when I do this. What if they have you doing y is equal to x squared minus 8x plus 12, and then they set that equal to 0. And they ask you to solve for this. So this is another type of problem that you're going to see that's a little bit different. It's the same thing, only they give you that last stipulation that's going to be equal to 0, and they ask you to solve for that. Well, what does that mean? Okay, your first step is going to be to factor out. So factor out this polynomial. That means x squared minus 8x plus 12 is equal to 0 now. The only difference is equal to 0. You're saying equal to 0. Let's say, so that's equal to y. So if you think about it, okay, so I'm not going to say too much. Your a is equal to the number in front of x squared is 1. Your b is going to be equal to negative 8. Your c is going to be equal to 12. If your a is equal to 1, you can use the technique that we've learned so far, which is this. Take your two numbers that multiply up to your c and add up to b. Okay, so in this case, that's going to be, your c is going to be positive 12 and negative 8. In case you forgot, I tried a bunch of numbers like 12 and 1. 12 and 1 don't work because 12 times 1 is equal to 12, but doesn't add up to negative 8. Okay, then I tried like some negative numbers like negative 12 and negative 1 because I knew that negative 12 times negative 1 would multiply up to a positive 12, but did not add up to negative 8. So I figured out that my answer was negative 6 and negative 2. So this is almost the exact same problem as what we did before. Okay, negative 6 and negative 2. That works. Okay, that works out. So my final answer should be x times some number times x plus some number. We know those two numbers to be negative 6 and negative 2. Okay, so that should be now x minus 6 times x minus 2. But, x minus 2. But don't forget, the only difference is this time it's going to be weird and say it's going to be equal to 0. So let's go to a third step. If you think about it, what two numbers, so x here and x here, you have to make this whole thing multiply out to 0. That sounds really hard, but if you think about it, you just have to think of an x value that you can plug into this parentheses and make this equal to 0. Because if you can make this equal to 0, 0 times whatever x is in here will make this 0 too. 0 times anything is equal to 0. So think about it like this. X minus 6, let's set that equal to 0. We have to find an x value in here that you can plug in that will make this 0. So x plus minus 6 equals x minus 6 is equal to 0. What would that look like? You add 6 to both sides. Okay, x minus 6, you set it equal to 0. You add 6 to both sides, and then you get x is equal to 6. What does that mean? Hold on. Just 1 second. What the heck does that mean? That means if I know x is equal to 0, okay, and I plugged in 6 in here, so let's just put imaginary. Let's just do this in our head. Let's actually add in 6 into here, and 6 into here. 6 minus 6 is equal to 0. 6 minus 2 is equal to 4, but the 0 here times the 4 would still be equal to 0. So I found an x value that solves for this problem. That's not too bad. Okay, those are things that you don't need to write out. You just need to understand. Okay, and then you have to take the other guy, x minus 2, and set him equal to 0. If we add 2 to both sides, then I get x is equal to 2. Okay, so that's your x. So to be honest, if you think about it, all you do is you factor it out. Okay, then you get two binomials. you set those binomials equal to 0, and then you solve for x. That's it. That's all you have to do. But again, what does that mean? That means that I'm trying to solve for the x values that make the y value go to 0. So that means x equals 2. If you think about it, those are two numbers, or that's a number that if I plugged in 2 in here, 2 minus 6, and 2 in here, that would make this 2 minus 2 is equal to 0, and then 2 minus 6 is equal to negative 4. But you know what? This 0 times negative 4 is going to be equal to 0. So I found out the two x values in here that make my equation equal to 0, which is what I want, because in the very beginning, they set this whole thing equal to 0, and they asked you to solve for the x value, basically. Okay, so let's just erase some of that stuff so it's a little bit cleaner. Okay, so that's it. So to solve for it, you factor it out. So to solve for this, when it's equal to 0, you factor it out, like into two binomials. You still set it equal to 0. You set each of these guys equal to 0 and solve for x. That's it. Let's do one more problem, okay, that you can try. So with less talking, all right? Let's try x squared minus 10x plus, let's see, plus 7. Okay, so again, my a is equal to 1, my b is equal to negative 10, and my c is equal to 7. So we have to come up with two numbers that multiply to your c and add up to your b. Okay, that would be 7 and negative 10. Oh, sorry, I think I did this incorrectly. Hold on. Try this problem here. I think I got them mixed up the way I wanted it. So let's make c your 10, positive 10. This is minus 7, okay? Sorry about that. So here's our sample problem. X squared minus 7x plus 10. A is equal to 1, b is equal to negative 7, c is equal to 10. Let's put c has to go on the top, c goes on the or b goes on the bottom. Come with two numbers that multiply up to 10 and add up to negative 7. So let me try 10 and 1. 10 times 1 does not work. 10 times 1 is 10, but 10 plus 1 is not negative 7. How about 5 and 2? 5 times 2 is 10, but adds up to not negative 7. But you know what? I noticed that 5 plus 2 is equal to positive 7. What if we try negative 5 and negative 2? That would be negative 5 times negative 2. Negative 5 times negative 2 is positive 10. Negative 5 plus negative 2 is negative 7. So my final answer is, or my answer is going to be x minus 5 and x plus negative 2. This will simplify out to be negative x minus 5 times x minus 2 is equal to 0. Okay. Then the next step is to take this x minus 5, set that equal to 0, and x minus 2, set that equal to 0. And then you're going to add 5 to both sides. Oh, sorry. You're going to add 5 to both sides on here. You're going to get x equals 5. And to solve for this one, you're going to add 2 to both sides to get x equals 2. Okay. That's it. That's your answer. But I know you're not happy with it. Let's figure out what just happened. Let's go back to our last problem here. And let's talk about what happened conceptually. So let's go back to the graph. Let's go down. Let's turn off this graph. So again, I went to y is equal to, went down, turned off the second graph, only left it in this way. So this is what we had, x minus 6. So back on my right hand side, on your right hand side, so x minus 6 times x minus 2 is equal to 0. And go back on my calculator side over here to the left, left here to the left hand side here. Okay, let's go graph this guy. Now, what is so special about x equals 6 and x minus 2? Well, let's go ahead and trace it. And let's just plug in 6. Let's press 6 here. Look what happens at 6. My y is equal to 0. Oh, and look at it. It intercepts the x-axis. And what do you think is going to happen if I press 2? X equals 2. That's also where the x-intercept is. Well, what do you know? I just figured out where the parabola crosses the x-intercept. Okay? That's what you're solving for. That's why when they said, because you're solving where y is equal to 0. Like if you look at the right-hand side, and I'm pointing to this, if you think about it, I set this whole thing, this is equal to this whole equation is equal to 0. I'm finding out where y is equal to 0. At which x values is y is equal to 0? Well, when x is equal to 2, y is equal to 0. And when x is equal to 6, y is equal to 0. One other cool feature about this is if you go, so that trace button, if you press second, this blue button over here, and then trace, let's go to intersect. Let's see, or I think it's 0 or intersect. I believe it's 0. Is it intersect or 0? I think it's 0. Okay. Let's say I want to figure out where the x-intercept for this guy is right here. I know that y is equal to 0 there, but what I'm going to do is I'm going to kind of, this says left bound. I'm going to try to put like a little wall right before that x-intercept right here. So that I know that point's right there. So I'm going to put a point that's to the left of where I want to find out the x value. I want to find out the x value right there, but I'm going to kind of, not directly on that dot right here, but I'm going to go to the left of it, just a few points. I'm going to press enter. You see how this is you see that little wall right there? It sets up like a nice little wall. If I go to the right, it's going to ask me for a right bound or right boundary. I'm going to try to trap. So I'm going to go to the right of where I want to find out where that x-intercept is. So I'm going to, so that's where my x-intercept is. I want to go to the right of it by going to the right a few times, press enter. So now in between these two arrows is that point right there. It's going to guess where the where y is equal to 0. So it's a guess. I don't know. I'm just going to press enter. There you go. X is equal to 6. So that tells me right there at that y-intercept, or I'm sorry, that x-intercept, that the x point is equal to 0. Let's try that for the other point right here. Second, calc, go down to 0. Left, so I want this one over here. So I have to go to the left of that point. So look, I'm going to keep pressing my arrow to go all the way to the left. Okay, so right on that point here is the x-intercept, but it asked me to bound it to the left of it, make a left boundary to trap that point. So my point's right around here. Let's go to the left a few times. There you go. So to the left of this, I'm going to press enter. That sets up a wall. Like you see that arrow? That sets up a nice little wall to kind of trap that 0 there. And it's going to ask me for right bound. So instead of going to the x-intercept, I'm going to go a little bit to the right of it. Okay, so there's the x-intercept. I'm going to arrow down a few points to the right of it. Press enter. So now I'm saying that in between these two arrows is where my x-intercept is going to be here. I press enter one more time. There you go. That's my other x-intercept. So I'm going to go over this again in class maybe, but yeah, those are some tricks that you can use for the graphing calculator and how to kind of go about 1-6. Okay, guys, I'm going to stop right there. There's a lot of information you guys got to take in. Watch this video a few times until you guys get this down, okay? All right, guys. Well, thank you guys for watching, and you guys take care. Bye.